A very warm good morning, sir. I'm Shreya Alex American of Department from ECB presenting here about digital signal processing. As we know, the use of digital signal processing. Computers or more specialized digital signal processors perform a wide variety of signal processing operations. Before stepping into DSP, I'd like to share the contents included in this topic. I'd like to share about digital signal processing DSP, signal sampling, domains, implementation, application, techniques, related fields of DSP, and for reference and further readings to know more about DSP. So now I can start from what is DSP or about DSP. Digital signal processing (DSP) is the use of digital processing, such as by computers, is more specialized digital signal processors to perform a wide variety of signal processing operations. The digital signals proceed in this manner are a sequence of numbers that represent samples of a continuous variable in a domain such as time, space, or frequency. In digital signal in digital electronics, a digital signal is represented as a pulse train, which is typically generated by the switching of a transistor. Digital signal processing and analog signal processing are subfields of signal processing. DSP can involve linear or non-linear operations. Digital signal process is also a fundamental to digital technology such as digital telecommunication, wireless communications. DSP is applicable to both streaming data and static stored data. And here's a figure of digital signal processing, which signals are moving. Analog signal, incoming samples, outgoing sample, and the time taken by it. Now, I like to speak about signal sampling or signal processing. To digitally analyze and manipulate an analog signal, it must be digitized with an analog to digital converter. Sampling is usually carried out in two stages: discretization and quantization. The Nyquist-Shannon sampling theorem states that the signal can be exactly reconstructed from its sample if the sampling frequency is greater than twice the highest frequency component in the signal. Theoretically, DSP analysis and derivations are typically performed on discrete time signal model with no amplitude inequalities created by the abstract process of sampling. Domains. In DSP, engineers usually study digital signal is one of the following domains: time domain, one-dimensional signal, spatial domain, multi-dimensional signal, frequency domain, and wavelength domains. They choose a domain in such a way which to process a signal by making an informed assumption as to which domain best represents the essential characteristics of the signal and the processing to be applied to it. Time and space domains. Time domain refers to the analysis of signals with respect to time. Similarly, space domain refers to the analysis of signal with respect to position. Example, pixel location for the case of image processing, etc. And the most common processing approach in the time or space domain is enhancement of the input signal through the method called filtering. Frequency domain. Signals are converted from time or space domain to the frequency domain usually through use of Fourier transform. Fourier transform converts the time or space information to a magnitude or phase component of each frequency. Z-plane analysis. Digital signals come in both IIR and FIR types. Whereas FIR filters are always stable, IIR filters are feedback loops that may become unstable or oscillate. The Z transform provides a tool for analyzing stability issues of digital IIR filter. Wavelength. In numerical analysis, the functional analysis a discrete wavelength transform in any wavelength transform of which the wavelengths are discretely sampled. The advantage is it has over Fourier transforms is temporary resolution. It captures both frequency and location information. And there are some of the images of Implementation. DSP algorithms may be run on general-purpose computers and digital signal processors. DSP algorithms are also implemented on purpose-built hardware such as application-specific integrated circuits. Technologies for digital signal processing include more powerful general-purpose microprocessors, digital signal process controls, and stream processors. This is essentially no different from any other data processing except DSP mathematical techniques are used, and sampled data is usually assumed to be uniformly sampled in time or space. An example of such an application is processing linear photographs with software such as Photoshop. Applications of DSP. It is two types: audio signal processing, audio data compression, video data compression, computer graphics, digital image processing, photo manipulation, speech processing, speech recognition, data transmission, radar, sonar, financial signal processing, economics forecasting, seismology, biomedicine, weather forecasting. Specific examples include speech coding and transmission in digital mobile phones phone. Correction of sound in hi-fi and sound reinforcement application, analysis and control of industrial process, medical images such as CAT scans and MRI audio crossover, and equalization, digital synthesizers and audio effect units. And it is some images of digital image processing, data transmission, seismology, use of DSP in medical fields, embed audio data compression, and its radar. Techniques for DSP: bilinear transform, discrete Fourier transform, discrete time Fourier transform, filter design, Gaussian algorithm, LTI system theory, minimum phase, S-plane, transfer function, Z transform. And the related fields of DSPs are analog signal processing, automatic control, computer engineering, computer science, data compression, data flow programming, discrete Gaussian transform electric engineering, Fourier analysis, information theory, machine learning, real-time computing, stream processing, telecommunication, time series, wavelet, etc. related fields of DSP. And now it is analog signal processing. There is some images of data flow programming, Fourier analysis, real-time computing. These are different fields which related fields of DSP which we can study more. And now I'm talking about reference. We can read about Walden RH analog to digital converter survey analysis. It's good book. Candice E.J. Written by Candice E.J. Backing, and Introduction to Computer Sampling. Stanley Dag by Digital Signal Processing Applications. JPFix. Further readings to more. N. Ahmad and K. Rao orthogonal transform for digital signal processing. Jonathan M. Backledge, Martin Turner, digital signal processing, mathematical and computation methods, software development and application. Harvard Publications and James Reports, etc. I think you like my presentation well. Thank you for watching. Have a nice day. Thank you.